Hello Finxters, today we're going to be looking at generators in Python and getting some understanding of what they are. So the topics we're going to cover in this video. We will look at normal functions versus generator functions, and we'll discuss the yield statement and the next method which are used with generator functions. We'll define some of the jargon we use in Python and iterate, iterable, all of those words that you hear a lot of. Most of you will know what they mean, some of you may not, so we'll clarify that. And we'll then introduce anonymous generators, and finally we'll discuss why and when you might use generators. So we all know that a normal function loads the entire sequence of the function to memory before returning a result, and once the function is executed, it runs, it terminates, and then forgets all the variables, and it will return the answer that you're seeking from that function to you. That's it, job's done. With a generator function, it will only load the first evaluation that is required, and then it will pause, and it will wait for a call to evaluate the next step in the function. And this allows a step-by-step evaluation of the function, and during that pause stage, all variables and the position in the function is remembered by the Python code. So let's discuss how that works. So we've got two things, a yield statement and the next method. So when you do a normal function, you use the return statement. Generators will use yield. And yield is the thing that causes the pause in the function execution. So upon encountering yield, Python will await a call before evaluating the next value. So it will carry out the evaluation and it will return the first value when it hits yield, and then it will sit and wait. And it will sit and wait until you call it, and to do that you use next. So then you're asking it to evaluate the next piece of information and return the next value in that function to you. And on receiving it, loads and evaluates the next expression, and therefore for a function to be a generator, at least one yield statement must be present. So you can have returns, you can have prints, you can have those other things, but if you don't have a yield statement, it's not a generator. So let's talk a little bit about some of the jargon we come across when we're talking about functions and generators in particular. And people talk about iteration, iterables, iterator. I just want to clear up for some people what all that means, because it can be confusing. So when we say in English to iterate, we mean to repeat something. So it's to repeat a task or an instruction. And if we are doing iteration, that's the process of repeating something. So if we're repeating a task over and over again, that is iteration. So an iterable is a collection of elements that you can return one at a time. That is something that is able to be iterated through. So we know iterables are lists, for instance. We can iterate through a list and return the elements one at a time. And then an iterator is an object used to return one element at a time during the iteration process. And the generator function will return an object which is an iterator. So with that cleared up, let's move on to why we would use generators. So because of that ability to only evaluate one element at a time and then return that element and pause, it allows us to evaluate a large data set one element at a time. So instead of a normal function that would load up the entire data set, and for some of the really large ones that exist, it would effectively take all your memory and crash the system, or it would certainly make it run very, very slowly. With generators, it will only do the first one until it hits the first yield, return that, and then wait. So you can step it through one element at a time. So normal functions are great when it's only small things that are being done, but if it's data intensive, a large data set, you have the potential to bring the system down. And so the generators will load and evaluate only up until the first yield statement, And so we call them lazy iterators for that reason. They're just lazy in that they're only doing the first bit and then they're waiting. And they will wait until you tell them to do the second bit and then they'll wait. So generators are really memory efficient, and it's a really nice clean way of creating an iterator object. And we normally use a generator in a loop, and I'll show you that in the code very shortly. And another thing that I'll show you in the code is the ability to create anonymous generators for one-off use. Very much like the lambda expression is an anonymous function, we can create a similar thing called an anonymous generator. So instead of defining a function, you can just do it in the line of code, and it will do what it needs to do, much like a lambda expression, and then job's done, returns what it needs to. So we can pass generators to normal and generator functions as arguments. As you know, you can pass one function to another, and with generators, so too can you pass a generator to a function or a generator to another generator. So you can pipeline these things. So let's go and have a look at that in the coding. So first off, let's understand just an ordinary function. We've defined a function here called multiply, and we're taking an argument which we've called num here, and we're just saying we want you to total num by 52 and return that total to us. So when we call that, we're saying multiply 6. We're going to print that to the screen, and you'll see that it gives us 312. But of course, it's loaded that up, it's executed it, it's returned it, and it's shut down again. So now if I was to call this print on total after having called multiply 6, you'll see that it won't understand what we're talking about because total doesn't exist anymore. Total is gone. The function is over. So that's an ordinary function. Now let's have a look at a generator. So we've got a similar type of function here, but it's a generator function. So we're doing multiply again, and we've got num, but then we're doing a number of steps. First, we're going to take num and multiply it by 52, as we did previously, and we're going to yield that. Then we're going to take that result, or sum, of num times 52, and we're going to add 185 to it. And then we're going to yield that. And then finally, we'll take that sum of that, we will take 76 off it, and we will yield that. So we're going to call it the same way we did previously, test equals multiply 6, and then let's just see what happens once we call next. So you remember that when you call the next method, it will give you the first yield statement in this. So it will run through, it will evaluate this expression, and it will yield 52 times 6. So let's do that now. And so once again, we get the same answer, 312. But now we have the ability to step through to the next one. So if we run that again, now it's given us the 497, which is the 312 plus 185. But still we have another step, which is the subtraction step. So we can do another next. And there we have the 421. So all three steps have been returned, but each time Python only evaluated up to the first yield, then waited. Then when we called next, it evaluated to the second yield, then it waited. Third next, third yield, now it's waiting. What happens if we call another yield, even though we don't have another step? Let's look at that. And this is where you get what's called a stop iteration exception. It can only yield those three things that you've actually given it to yield. If you ask for a fourth call on this particular one, you'll get a stop iteration exception. So just be aware of that with this process. You can only ask for what's in there, otherwise you'll get a stop iteration. Now, one thing that we do with generators is we use them in a loop. And a loop is a convenient way also of managing the stop iteration exception, because a loop by definition usually has a conditional stop in it. So 4 item in multiply 6, there are only 3 items. It's not going to ask for a fourth. So you can use this generator in a for loop to produce the answers you want. And the interesting thing about that is for loops are an abstraction of an iteration process. So they abstract away some of the detail, which means they are using the next method in the background automatically. So we are calling, by using the for loop, we are calling next on each of those yields, and then we're stopping. So let's just do that. And once again, there you see the answers that we would expect. Now, one of the things we can do with generators is, rather than define them formally as we did previously, we can use anonymous generators. Now, those of you who are aware of lambda expressions or have done list comprehension, this will be a fairly easy thing to understand. So in front of you, there is a standard list comprehension where I have a list, numbers 1 through 8. I have a calculation to be done here for x in numbers. I return an answer and I print that answer, and it will return a list with the answers once that calculation has been carried out. So what we can do with an anonymous generator is we can follow a very similar syntax. So let me show you that. So notice the syntax in this. So we have the original list and the list comprehension and printing the answer, but now we're doing another one which looks very much the same, but this time, instead of using the square bracket notation, we're using round bracket notation. So if you're going to use a generator in a one-liner like this, you simply need to use the round bracket notation, and it will do the same thing as the generators we saw previously. So before we actually step through that and show you, let's just show you what a print on this result will give you. Because we've seen print on answer for the list comprehension, it gives you a list with that calculation carried out on all the numbers. But let's see what a print on result will give you. And here you can see that this is returning a generator object. So this is the iterator that we were talking about previously. So it returns an object that we can now go through one by one with the next command. So if I do the first next command, and there you see it returns 3. For the other commands, let's do them all. It will do the same as we saw previously, in that it will step through one at a time and return from that generator object that was created. So what we've effectively done here is we've created an anonymous generator. We haven't had to define it, we've just done it in line. We've passed the information to result, but then we can actually step through result one at a time and drag out the data we need. Remember, of course, that you can only go one way through a generator object. You can't backtrack. So you call the first one, you call the second one, you call the third one, however many there are, and when you finish, you're finished. That generator object is done. You would need to call another generator object if you want to carry out those calculations again. And the last thing to understand about generator functions is that just as we can pass functions to functions, so too we can pass generator functions to ordinary functions or generator functions to other generator functions. So in this situation, we have our generator function that you saw previously, and we've just passed it to the max function, which will give us the largest number from the result, which is created by that generator function. And that returns 27 down the bottom here. Okay, let's just go back to the slides. So to summarize what we've done today, we compared a normal function to a generator function, and we introduced the yield statement and the next method. So for a generator function to be a generator function, it must have at least one yield statement in it. The next method is used by the caller to then evaluate one element at a time. We clarified a little bit of jargon, the iterate iterable discussion that we had earlier, which sometimes confuses people. And we introduced anonymous generators. So if you don't wish to formally define a generator function, you can call it in the line of code for a one-off application. And then we discussed why and when you might use generators. And I'm sure you can see that rather than load a large data set, we can run through one at a time using a generator, do an evaluation, return a result, and wait, then do the next evaluation, and we're much more memory efficient than we would have been if we were using an ordinary function, which would have loaded the entire data set. So that's it for today. Thank you very much for listening, and I'll see you in the next video.